Hello guys, my name is Arun and welcome to my channel. This series is actually a series of tutorials on Fortran hacks. Okay, now if you guys notice, I already have two tutorial series, like mainly Fortran programming and advanced Fortran programming, wherein I'll be covering some basic as well as some advanced concepts in Fortran. Now, the thing is, there are a few topics which I did not talk in those series, those two series which are kind of necessary and kind of becomes important and handy for many advanced Fortran programmers. So those kind of topics which I have not talked over there and which are like very interesting and will be very handy, I'll be talking in this series. And unlike those two series, this is kind of this is kind of the specific with different topics, so this doesn't follow any specific order, so you can watch these videos in any order, so without losing any continuity unless otherwise specified. Okay, that's about it. And besides, and one more thing is that this video series for this video series, if you're watching it, I suggest you have some basic understanding of how Fortran works. Fortran works and some of the concepts behind it, because I'll be dealing with some advanced concepts over here, which if you're like a newbie, you might not understand what's going on. But if you already know some basics of Fortran, to some extent, you guys will follow quite nicely. So no problem. Okay, in today's topic, I'll be explaining guys how to write data into a binary file and read the data from the binary file back. Okay, now here's the thing. If let's say you're doing some computation and you generate a lot of data, then it will be practical and realistic for you to store the data so that you can use the data some other time. Okay, now you have several programs to store the data in several different file types. Fortran provides kind of two kinds of files, like ASCII files or text files. Other one is like a binary file. Now here's the thing. If you were to store data, if you were to store data, then what will happen? What will happen is that based on that file type we chose, the speed and the advantages have differences. For instance, if you store data in a text file with certain format, okay, you can use any text editor or any program to open it and access the data quite easily. Okay, and the advantage of text editor is that it kind of becomes easy to notice what pattern is. Okay, and one disadvantage, I won't say a disadvantage, and one more thing about text file is that you can figure out the format in which the data is written inside by opening it. Okay, now here's the thing about binary files. Now, they are like different category. Binary files are actually much faster when compared to its equivalent text files. Reason is because unlike text files, binary files are written with have the data written in ones and zeros, whereas text files you have the ASCII or UTF-8 coding, web coding or encoding or something like that playing on the top, so that which acts as a translation. As a consequence, binary files binary files are quite faster in reading the data, quite faster in execution, so it's easy to store data and read data from them very quickly when compared to text files. The other one more thing is that binary files are not easy to be opened using other programs, so it's kind of like uh, difficult to find out what value is written inside by opening it's kind of difficult to open it, so that kind of becomes a disadvantage for disadvantage, but it also serves as an advantage if you want your data to be sealed and concealed nicely. Okay, those are the pros and cons. And I actually have talked about how to extract data from text files quite extensively in my programming tutorial series. You can just have a look at that. Now for binary files, I'm explaining guys today. Now in binary files there are two categories. One of them is formatted, another one is unformatted. And just like other files, you have binary files which store the data sequentially and then directly. Okay, I'll be explaining guys all these concepts today. Now the thing about formatting is simple. Like if you had to write the data into the binary file in a particular order, with some restrictions on how they look like, and even with the number of decimal points and everything and stuff, then it's formatted. If you write them just like that without any kind of restriction of how they look, then it's unformatted. Simple and sweet as that. Okay, that's the thing. And about sequential and direct access, is just like your other file reading from Fortran. In sequential access, the data is stored in a sequential manner, and we have to read. If you have to read, if there are like 100 values, if you have to read the 700 values, 700th value, you have to read from all the values from 1 to 699, throw it, and then you have to read it in the 700 value. So it's 700th value, just like that. Whereas in direct access, if you want to read the 700th value, you can just skip all the others. You can just directly access the 700th value, just like that. That's how access sequential and direct access works like. Okay, and for more details, just refer to one of my previous videos. You'll have an idea about it. Okay, I'll explain you guys this program I written. I have declared four values m to m and o and p for defining the sizes of the arrays a to f, dimension of the a to f, and defining six four-dimensional arrays a to f, which store 8 byte floating point values. Okay, I decide the size of these arrays over here, m and op, and in this line I give the value of how big each array is, and then I'm allocating the values a to f over here using the sizes, and then I set the value of a and b over here. Okay, because I cannot just write empty values, right? I just need some meaningful with data. I'm just setting all the values of a to 2 and b to 10, and then I'm making c to be the addition of a and b, and here I'm writing the data. Here I'm writing the data to the output file name out1.bin. That bin is actually the binary data format, nothing more. And then I'm writing this without any format. I'm writing it sequentially. For now I'm writing it sequentially, and now after some time I'll be writing this in a direct access file. Okay, now next thing. Now what I've done next is that I'm just writing the data directly into the file A. Writing the data A directly into the file. Since I'm not going to use any formatting, I don't have to worry about the manner in which it is written. It will be taken care of, and I'm just writing A directly into the file, just like that. Okay, no formatting, no loops and everything, just like that. How simple is that? Okay, that's very simple actually, if you ask me. That's very straightforward. And next, what you do is that after writing A, I'm writing B, and then I'm writing the array C over here. And these print statements are actually for my convenience, so that I understand whether I'm writing whether this writing process is over or not. That's it. That's about it. And then I'm closing the file. And immediately after closing the file, I am reading the data from the same file. I'm opening the same file again. This time I'm reading the data. I'm reading the data. First, I read the value A into the array D. Next, I read the value B into array E, and read the value C into array F, and then close the file. And then I'm printing the values, the maximum value of D, E, and F, so that I get to know whether I read it properly, and then I'm deallocating it. Okay, now I can set the sizes of M and O over here. Right now I'm setting all of this to be 10 times 10 cross 10 cross 10 cross 10 4D arrays. So this array will have about 10,000 elements, and each of this element is an 8 byte floating point value. So it will be 80,000 bytes long in memory wise. So it's 80 kilobyte. Each array will be 80 kilobytes. So since you're storing 3 arrays A, B, and C, it will be 240 kilobytes in size, maybe slightly extra. Now I compile this, build this using the commands in Genie, and then I execute it, and there you go. It says it just says return data, return A, B, and C, and it started reading the values, and it's printing them properly. So thereby this value coming out to be exactly same as A, B, and C. This is an indication that the reading and writing has occurred nicely. So if you want to write the data in a binary file, in an unformatted manner, just use them directly, just like that, simple as that. Okay, and and here's the catch about binary files. See, if you look at the output files over here, this is actually the binary file, and if you try to open, your program will not be, all the default programs in your operating system, whether you're having Windows or Mac or Linux, it doesn't matter, they will not be in a position to know how to open it, because this is accessible through executables, and executables only. So because it's written in zeros and ones, okay, so your normal programs will not be in a position to open. However, you look at the properties of it, it's super compact. That I have three arrays, and each array is 80 kilobytes, so your total size is 240 kilobyte plus just 24 bytes extra. And this 24 bytes is actually for maybe for storing the array values or some kind of internal stuff. And how good is that? It's like, it's super proper. And since I've written this without any formatting, it's exactly the same size. You can actually literally with a pen and paper, you can calculate how big it is. How good. Now, if you were to write the same thing with formats and everything, you might have to break your head a little bit to calculate how big the sizes will be, and that's the thing. Okay, and that's how we read and write. And next thing is when you're accessing binary files. Here's the thing: you read the data in exactly the same manner and order in which you write the data in it. For instance, I'm writing A, B, and C in this order. First, I write A, and then B, and then C. Okay, whose sizes are defined over here. Okay, now the thing is, I have to, if I were to extract the values A, B, and C, I have to read them in the exactly same order in which I wrote them. I wrote them. Otherwise, what will happen is that the reading will be no, will not match. If the reading does not match properly, the values might turn out to be faulty or incomplete or partly read, something like that. So you just have to use it properly. So as a consequence, it's all. I mean, as a consequence, if you're writing in data into a binary file, it's always advised you read and write the data in exactly the same manner that exactly the same manner. So if you have a subroutine or something that writes data into a binary file, you can mimic the same subroutine and write your own subroutine, which kind of looks exactly the same, to read the data back from it in exactly the same manner. Okay, and that's about reading and writing data from sequential binary files. Now let's go into a little more sophisticated. Let's go into direct access binary files. Now that this is actually the quite exciting, because here's the thing. Now now here's the thing. Now I wrote the data sequentially, so as a consequence, I have to, if I write A, B, and C, I have to extract A first, and then I have to extract B, and then I have to extract C. So if I want to directly access C, I cannot do it. I just have to access A and B, finish it, and then go to C. And then if I want to access, after accessing C, if I want to go to A, then I have to move my file pointer back to the beginning of A to read A and B back. So that's how the problem is sequential. Whereas on direct access, if I want to access C directly, I can just access it just like that directly, or in any order, it doesn't matter. So what I'm going to do, I'm going to comment this line, comment these lines. Okay, this I need. I'm going to uncomment these lines, thereby reading the data and opening the data in a direct access file. And then when I do that, I need to specify this additional parameter called as recal. Recal actually stands for record length, and here it kind of helps. Now what this record length is as follows. If you were to write data into binary files in direct access format, okay, you just have to specify the limits of the data. For instance, record length gives you one continuous stretch of memory in size wise, in which data will be placed consecutively. So written Raquel to be m times n times o times p times 8, so it's going to store uh, since values of m and o and p are 10 each. It's going to the record length here will be 80,000 bytes. So my first record, so if I were to save an array, okay, I'll have one record length. I'll have my record length for each okay, let me put this in a simple manner. I think if I were to open this in okay, what was that? Card man. Okay, I think I'll just explain this properly. Suppose if I have a text file, let's say, a binary file, let's say, which which is like this. Now what happens with the direct access file is that in sequential it's easy. In sequential it's easy. In a sequential file, you don't have to specify any record length. So as a consequence, it will start writing over here, and once that end is over, you write next line, next line, next line, and so on and so forth, and goes on. Whereas in direct access, files, what happens is that the entire file will be like this, okay. And if you want to access any files, the file pointer will just directly jump into the data, into any data that you want. So if you want, for instance, here in sequential, if I wrote a over here and b over here and c over here, if I want to access c, I have to read through a, read through b, throw them away, and then read c. I cannot access C directly. On the other hand, in direct access, if I written A over here, B over here, C over here, I can directly access C without having to go through A and B. So as a consequence, it's kind of necessary that direct access files, you have to split or partition the files into sectors, and these sectors or boxes are actually called as records. Okay, so it's like it's like in a book you have chapters. You divide if you have a story book, you divide the story into several chapters, and each chapter is like a record of one part of the story, right? So these are called as records, and each like that in this binary file with direct access, each one of these sections of the file partitions are called as records. And the records have a name to it, like the records have a number to it. So this can be your record 1, this is your record 2, 3, and this is your record 4, 5, 6, 7, 8, 9, and so on and so forth. Now here's the thing. Now the records will have an automatic numbering which you have to specify accordingly, and then what happens is that you have the numbers ready for the records, and then you have to specify how long the records are. Now as far as direct access binary files are concerned, all records are equal in memory size. So as a consequence, if one of your record is say 80 kilobyte, then all your records have to be 80 kilobyte. So this size specification, like each record is like 80 kilobyte, is actually defined by your record length. Now that's what I meant over here. It's actually the record length gives you record length tells your Fortran program to say that okay, this binary file, the records are being broken into this much small segments, and writing will be taking place in these in one shot. So what happens is that if you want to write a data into say record 4, let's say, the data will be written kind of sequentially in this, and you don't have to worry about accessing record 1, 2, 3, 5, 6, 7, 8, or 9. You don't have to worry about it. Directly the data will be written into record 4 if you specify record 4, and then it can be done directly without even worrying about 2. And similarly, if you want to write 6 without worrying about anything else, you can write it and read it just like that. Okay, so this record stands for record length. Next, what I've done here is that now since this record length is written, I need to write the data by specifying the record number. That's kind of becomes mandatory. since I'm using direct access files here. So thing is, since I'm writing the data in a not so sequential manner, in a in a scattered manner, it's necessary for me to write the data in the I just have to specify a name tag or a label or placeholder for each of these records, and that is now that they have to be numbered. They should have their own ID or a name like that, and that name is actually your number. Each record will have its own number, and that number is actually your rec. Rex says that okay, write this data as record number one, write this data as record number two, write this as record number three. Just like write this content as chapter one of this story, write this as a chapter 10 of that story, like that. So other than that, the exact procedure is the same. And if you want to access the data, you have to follow exactly the same procedure as it is, and the record length should be the same. Okay, now here's the thing. Here I've defined the record length to be the entire array. So what I'm doing is I'm just writing the entire array in one shot. So I have to mention the record length to be equal to that of the array. Can I break my array into small record lengths and write it? Yes, it's possible. Like meaning your record lengths can be the size of two rows or something. So you can write two rows at a time in your array, and you can do that for more clarity. Okay, for simple purposes I'm writing the entire array into one record, so I'm really keeping it like this. So if you guys want, you can break it up as per your convenience, so it's not a problem, but only consideration is use them accordingly. And here's the thing, since I've written over this, it's I have to read them with the record lengths. Okay, read them with the record lengths. So with this way, let's look at this program. Let's look at this program. I'm writing the arrays A, B, and C with record names 1, 2, and 3, and I'm reading the same reading the same records 1, 2, and 3 into the arrays D, E, and F. As a consequence, A will be stored to D, B will be stored to E, and C will be stored to F. So if I were to compile this, build this, and run this, voila, you have the same data, no problem. But here's the catch. Now they look exactly similar, and the speed might have looks exactly the same, right? Now here's the thing. Now let me cut this and paste it at the bottom here. Now what I'm doing is I'm deliberately changing the order of the records. Now I'm writing the records in 1, 2, 3, but I'm reading the records from 2, 3, and 1 in the order 2, 3, and 1. So if this were to be a sequential file, let's say, then A will be mapped to E, B will be mapped to F, and C will be mapped to D, and the values over here will be 12, 2, and 10. Now here, because of this record feature and record length feature, and because of the direct access access formatting over here, the A will be mapped to D, B will be mapped to E, and C will be mapped to F because of this record numbering. So let's check how true is this. So I'm compiling this, building this, and executing this, and there you have it. I'm reading the files in a random order, but the values are exactly the same. Now that is the best advantage of direct access unformatted binary files. You get to write the data in the same order and same manner. Okay, and you can just play around with it and extract any data you want. On the other hand, if you use a sequential file, you have to extract all the data in front of it before accessing the data. On the other hand, if you just write it in direct, you can just access any data you want at any time, at any convenience. Okay, and even if you want, you can just mess it up, the order and everything. It's perfectly fine. You'll be fine. Okay, that's the advantage of sequential files and record length. So the main thing about the direct access file is that you just have to keep the record length proper, and you have to specify the records to read the files. I can break the record length into smaller bits. But the disadvantage of that is, you need to use loops, and you have to think about the record number generation properly to extract all the data. So you just have to think that little carefully, something like that. Other than that, it's not a big deal. This is kind of very handy and useful. Okay, and if you're running like a very complicated models or some lot of work, this will be very handy and useful. Okay, with that being said, that's all I have for you guys in this tutorial. uh, I mean, this video was actually taken in response to uh, one of my subscribers. Let me see if actually this video was actually recorded in response to this person, like San Truong Kong Huang. Sorry, I'm sorry, and I mean, I'm I'm not sure whether I read your name properly. And this person has requested and said that, can you just do a talk about writing data into a binary file with using record length and record, such that it'll be easy and easy. Like, I mean, he asked me about something like 3 weeks ago. I was not aware. I want to do this, but I was not that good in it, and I was like trying to figure out how. But fortunately, I kind of figured it out, so I'm able to do this, and I did this. So it was actually this video was actually in response to his request. So thank you, friend. I hope this video is very helpful for others as well, and hope you like this video as well. And that's about it. That's about that part. So thank you guys for watching, and see you guys next time. So till then, take care.